Hey everyone, welcome to Code Harmony. Today we are going to solve LeetCode problem 416. Partition equals subset sum. This problem is based on dynamic programming and asked in almost all the companies including TCS, Google, Amazon, TikTok, Microsoft. So it's very important if you are about to give DSA interviews. Also marked as medium. Let's have a look on the problem statement. We are given an integer array nums and we have to return true if you can partition the array into two subsets such that sum of the elements in both the subsets is equal, otherwise return false. The problem statement is pretty straightforward, and the length will go till 200 and array value will go till 100. Okay, they are saying that we are given an integer array, and this integer array we have to divide into two set. One element in one set, and we have to divide in such a way then both the sets are having sum equal. Okay, if both the array are having sum equal, let's say the sum is a, so a plus a is equal to total sum of all the elements, and total sum of all the elements are 5, 5, 10 and 20, 22. It is 22. I just got this sum in order of 1 and time by just doing one iteration. Now if a plus a is equal to 22, 2a is equal to 22 and a is equal to 11, it means this subset should be having sum equal to 11 and this subset will be having sum equal to 11. Okay, let me ask you one question. What if the sum is 23? If the sum is odd, it means we can directly say that we can't divide this array into two subsets. So our first condition should be array sum should be even. If it is even, we can divide it, otherwise problem is over. Okay, so just try to divide it into two subsets and using this element, and this is a set, or you can say subset of this nums array with sum equal to 11. So this problem is now reduced to the problem which is named as subset sum. So you are given a set of elements, or you can say array, and you have to figure out whether there is any subset exist whose sum is equal to target or not. This is something we have to do now. Let's say if I try to divide this array into two subsets of sum 11, it can be something like, if I pick 1, I place it here, and then 5, if I just pick 5 as well, and then 11 I can't pick because it will be crossing 11, some total required sum. Then if I just pick this 5, here the sum is 11, and what is the remaining element? All the remaining elements will go to the set 2. Because we have to use all the elements, all the nums items, all the integer from nums array. Okay, so this problem statement was, you are given an integer array and you have to divide it into two subset with equal sum, right? It means we have to use all the elements, and the subset sum we can directly figure out whatever is the sum, that is divided by 2. And if the sum is odd, we can add a condition that if it is odd, we can't divide it. If it is even, then we know what is the target sum and what is the array we have to take. So we have the array and we have the target sum. Target sum is 11, array is 1, 5, 11, 5. So now the problem statement is, from this array we have to return true or false, yes or no, whether there is any subset with the given sum. Okay, so how do we get that? To figure out the subset with the given sum, first thing is calculate all the subsets. Calculating all the subsets. If I calculate all the subset, it will be something around order of 2 to the power n. So instead of calculating all the subset, if let's say when I'm calculating subsets, I'm calculating first subset, second subset, third subset, fourth subset. If at the fourth subset I'm getting the answer, then there is no need to go further. Whatever moment you are getting your desired target sum, just close everything out. So this is something we have to keep in mind. And for that, what I can do, let's say my array is something like this: 1, 5, 11, 5. If I just pick 1, so 1 is in the set and remaining items are 5, 11, 5, and the target sum initially was 11, and now the target sum is reduced to 10. See, if I just again pick 5, my subset will be like this. Even if you are not picking this subset, there is no issue as far as you are reducing the target. So if you just pick this 5, remaining elements will be 11, 5. And what is the target? Remaining target is 5. So here the problem is reducing. Earlier we were having these many elements in the array. This is the given set. See, we are given a nums array. Okay, nums array is given to you and you have to find the desired target. Nums array is given to you, you have to find the desired target, whether it is existing or not. Nums array is given to you, you have to check whether this target exists or not. See, the problem is same. Problem and subproblem is same, as I always recommend. If both are same, then directly go for recursion. Let's first try to write down the recursion. And at any moment, if the target sum is 0, it means we have got the answer. I will return yes. What if like I just have target equal to 5 and I pick this 11 and target is reduced to negative value? If the target is less than 0, then I can directly say that no, this call is not going to give any answer. And what if I have used all the elements, there is no element left in this? See, this is step 1 and this is step 2. If I am coming to step 2, I have checked this condition. It means the target is definitely some value, definitely greater than 0. Right? Less than 0 we have checked, equal to 0 we have checked. It will be definitely greater than 0, so there is no need to check. It's understood. If elements are not present, we have used all the elements in the nums array and target remains positive. In that case also I can return no, that it is not possible. Otherwise, from all the remaining subproblems will get the answer. Okay, now let me just show you how I'm going to approach the recursive formula for subset sum, including the whole logic. What is our step 1? Step 1 is calculate sum. Calculating sum. If sum modulus 2 equal to 1, it means it is odd. Return false. There is no need to check further. After that, we can check subset with target equal to sum divided by 2. Sum is even, sum divided by 2 is an integer value, and this we can consider as a target. And how I can check that? From this solution function, I'm writing a helper function which is going to be a recursive function, which is going to take this given nums array. Apart from that, I will be giving an integer as well. That starting of the array 1, 5, 11, 5. Starting of the array, just keep on picking elements in some order. Just let me know after picking all the elements you are able to get your target to 0 or not. See, there is one more approach as well, that instead of target you just capture the sum, current sum, where the current sum equal to target. But I'm not recommending that approach. You can guess why I'm not recommending. Solution index target value, I will keep on reducing the target value. Then if at any moment I will just get the answer, I will break it. And yeah, and we have to keep in mind, whenever we get the answer, we don't have to explore further calls. We have to save our time. Now this is the template, and here we have to implement this function, solution of idx and t. Solution of idx and t. In our sample example, it was something like this. Solution starting from index 0 and target sum is 11. And what it is going to return? Return a boolean. See, first of all, there can be cases like this. If the target is less than 0, then I can directly return false. If the target is 0, I can return true. Now, if my index has reached the size of the given array, but when I'm coming to this position, I have already checked these two conditions. It means target is already greater than 0. Target is greater than 0, and I don't have any element to pick. It means definitely it is a false. Now we have two options to decide with current element. I am currently at this index 0. At index 0 we have two options. First one, to consider that. Second one, to not consider that. If I consider that element, I will be calling a function again with index plus 1, but this time the target is reduced to target minus I value. I am making this call. What if this call is returning true? If the call is returning true, then you also return true. No need to explore further. If it is not returning true, then keep on exploring. Do not take this element. Solution of idx plus 1, target will remain same. If not taking that element is returning true, then return true. This condition is very important, that you are applying some pruning. Whenever you are getting an answer, you are not exploring further. So these are our subcalls I'm calling. It means I'm doing the processing. These are my terminating cases. And what else? If these two conditions are not returning true, in the end return false. That is default value. So base cases, then processing, then return false. But there might be the possibility that let's say the array is something like this. See, currently the time complexity is order of 2 raised to the power n, because at every step I am making two decisions, either taking it or not taking it. If still you are not able to understand this approach now, if you are not with me, then I would recommend you just try to solve the problem with subset sum. Subset sum. And even before that, capture all the subset. Capturing all the subset is with done using backtracking, and subset with the given sum, it comes under dynamic programming. Why? Because there might be overlapping subproblems. Okay, so let's say the example is something like this: 5, 5, 11, 1. If I'm picking this one and if I'm skipping this one, I am at this position, which is solution of 2. But what is the remaining target? Remaining target is 5. And after some processing, I'm just ignoring the first position, taking the second element. I'm still at index 2, solution of 2. And what is the remaining target in this case? That is also 5. So here, if you just try to draw the complete recursion tree, you will realize that these subproblems are getting overlapped. If these subproblems are getting overlapped, just use caching. Before the processing, check in cache whether this is already processed and stored in the cache or not. If not, do the processing, and after the processing, cache this result. Okay, so if we just cache every single call, my call is dependent on index and target value. Target value will go till sum divided by 2, and index value will go 0 to n minus 1. So let's say we have n elements, or m can be the target. Then the time complexity is now reduced to n into m. And what about the space complexity? Space complexity will also be n into m, because we might take a 2D array to store the answer, or if not know the 2D array, map maybe we are using. But 2D array will work fine because the target value, see, we are having nums item is equal to 100 and length can go till 200. So 100 into 200, 2 into 10 power 4. And if I divide it by 2, it will go till 10 power 4. So this can be the size of our one metric. Second metric is already n. So we can take a Boolean array of size new Boolean array of n and m. N and m plus 1. So this is something I can take. In this array, what we are going to store? If the answer is true, I'm going to store true. If the answer is false, I'm going to store false. But this Boolean is by default initialized with false. So that is causing conflict. So in this case, what I can do is I can use a wrapper of your class, or in case you don't have any wrapper, then try to initialize it with the default value. Boolean, if I just use the wrapper in case of Java or some other languages, then default value is null. Default value is null. If it is the true answer, I just store true. If it is false, store false. At the time of before the processing, I will check whether this value is stored or not. Based on that, I will get my answer. Okay. Now this is the complete problem statement. Here what we have done is, first of all, we analyze the problem statement. Problem statement is something, the nums array is given and we have to divide into two sets, set 1 and set 2, such that both the sets are having same sum. If we have to divide into two parts, it should be divisible by 2. If it is not divisible by 2, then directly return false. Now if it is divisible by 2, in that case, my first subset, see, they only require the answer to be yes or no, whether we can divide it. They are not asking the exact answer. So firstly, just try to see if you can get some kind of subset from the nums array which sum to s by 2, total sum by 2. So now the problem statement is reduced to subset sum. You are given an array, you have to figure out whether there is any subset with the given sum. In that case, there can be two possibilities. First one is a brute force, calculating all the subsets, order of 2 to the power n. But we don't require all the subset. At any moment, if I see that okay, I will be able to get the subset value, then just return false, return true or false accordingly. So calculating or capturing all the subset is not going to make sense. So we are not capturing it. We are just maintaining target. That remaining array is this. Remaining array is this, starting from index 0, and we have to capture this sum. Now remaining array is this, starting from index 1, and we have to get the target equal to this. So based on this, we figured out that the subproblem is getting overlapped or is of the same nature than problem. If problem and subproblem are of the same nature, directly use recursion. What about the corner cases? Corner cases will also be dependent on t. If the target is 0 at any moment, then we have achieved the subset, return true, and close every other subsequent call. If it is less than 0, then this call is not going to give us the answer. Otherwise, just do the pre-processing by solving the subproblems. Okay, so this is going to be our main function. Main function will look like this. First of all, I need to calculate the sum. This is order of n time, and then I will check the condition if it is odd or even. After that, subset with a given sum, subset with the target equal to sum divided by 2, and this is our utility function. In the utility function, I'm going to check for the cache before doing the processing. Before doing the processing, I will check whether I have already solved this problem or not. Solve problem with this parameter, with this permutation, like with this combination of index and target value, and return value is boolean. So this I can directly store in 2D array, and that 2D array will behave like a DP for me, DP array. So after the processing, store it in the cache. So just normal standard template, standard approach of doing top down style programming. Now what is the time complexity? Here in this case time complexity will be improved from 2 raised power n to n. I'm writing n square, or you can say quadratic. Exponential to quadratic we have improved. And yeah, for the storing, what I'm going to do is I'm going to take a boolean wrapper class, because that class is also giving me option to store, to have a default value which is set equal to null, because false can also be my answer. Now let's write the code. First of all, I need to get the sum of this nums array. Before that, let's capture the length, nums dot length int. Let's say I'm going to capture that sum in the sum variable, so I have to write a loop iteration over this array 0 to n I plus plus sum plus equal to nums of I. Now at this moment just check whether this sum is divisible by 2 or not. If it is giving me remainder equal to 1, it means it is odd and I can directly return false. Otherwise I will be calling my utility function, where I will just tell it that start from index 0 in this nums, start from index 0 and look for the target which is equal to sum divided by 2. If you get the answer, just return it. Firstly, let's write the recursion only. Private boolean and solution integer array nums integer idx and integer target. This is the signature of my utility function. And first of all, what are the terminating case? Terminating cases are if let's say target is less than 0, I can't get the answer, return false. If at any moment target is 0, I have got the answer, return true. Now if I don't have any element left in my nums array, index equal to nums dot length. I can't pick any more element, but target is greater than 0 at this moment because both the other conditions are already checked. Then return false. Now start processing the idx element in nums. IDX element in nums, we have two possibilities. If we have to take it or do not take it. If let's say if I do not take it, my call will be something like this. In the nums, index will be incremented and target will remain same. But this call, I also need to check whether this call is returning me true or not. If let's say this call has returned me true, there is no need to check for further subsequent call. In this case, directly return. Or see, after this I am not writing anything, so I can directly return, say return this value. Okay, return this value. But before that, I might have to take it as well. So if I take it, nums array will remain same, index will be incremented. But if I have taken the current element, the target is reduced now. Target minus nums of idx. But if this call return me some answer, okay, if it return me true, then there is no need to go to the subsequent call. If it is returning true, then directly return true. Otherwise, just check for this case. Okay, this is my processing. Processing is over, and now let me just test whether my sample test cases are working fine or not. Sample test cases are passed. Let's try submitting the problem. It's exponential time, but let's see what happens. TLE as expected, only 37 test cases are passed. Why? Because it's an exponential time. We can do it a quadratic time because we have only two parameters and we know that these subproblems are getting overlapped. So for that, what I can do? I will be taking a wrapper boolean 2D array, and this 2D array I will be initializing with, let me name it TP. Initializing with new boolean. First parameter is my index. Index will go till n and the other value will go till sum divided by 2 plus 1. This is my target. Let me extract the target. Target is equal to sum divided by 2, and this value will go t plus 1, and this I'm going to pass t. So this DP is ready, it's global, it will be accessible in this solution as well. So before the starting the processing, I need to check if something is stored in the cache. And what I'm storing in the cache, when I'm returning from this, I'm storing somewhere in the cache the DP of IDX and T is equal to this. Also we are returning from two different positions, DP of IDX and DP of T is equal to this. So for this subcall I have captured the result here. For this subcall I have captured the result. Okay, so we are returning from two different positions, and for both the different positions we have captured the answer as well. Now we have captured it, and this is the time to check whether it is already processed or not. And to check that DP of IDX and DP of T, if it is not equal to null, in this case it is already stored, and directly return DP of IDX and DP of T. So this is something I was doing the processing, and when I'm returning the result after processing, I'm storing it, and here I'm using it. Let me run now. And now in this case every unique call of solution will be cached. Unique call means this nums is always constant. This can vary till 0 to n, and this can also vary from 0 to target. Let's run our sample test cases again, if it is working fine or not. Working fine. Let me submit again. This time it is submitted successfully and it is 90% faster. I hope you understood the approach. It's a very good DP problem and asked in almost all the good companies. But to understand in a better way and showcase in the interviews, you should understand and have a good recursive thinking. So practice good recursive problem. Thank you guys. Bye bye.